Today we're going over day 3 of our Algebra 1 Fall Midterm Review. Now, on my last video, it took a little bit longer than what I wanted. I went up to the 40-minute mark. So I'm going to try to go through this a little bit faster. One, so I don't have such long of a video, and two, this is a review and I have videos that go into more details of each one of these situations. The first thing that we're going to cover is functional relationships. With that, a function is a relation where the x value do not repeat. So in this case, what I mean is, using example 1 where it says which table does not represent y and a function of x. It's supposed to be y as a function of x. Well, what that means, since we are looking for not, we're looking for the one where we have a situation where x does repeat. For a table, we can simply look through our values of x and see if any one of them repeat. Going through, C has two x values of 2, which have a different y value. This is what it means by repeating, x values repeating, so C would be our answer. And just to check the last one, D does not repeat its x values. For function notation, this is referring to instead of using y equals, we use f of x equals. It lets us have an idea of what our x value is going to be. In this sense, if I go through this, if f of x were to equal 3x plus 5, and I stated that f of x is actually f of 4, what I'm saying is I'm going to replace my x variable in the expression with the number 4. Now when we do this, we need to be careful. We need to show that we're doing the same action operation. So this is 3 times x. So in this case, I need to show 3 times 4 plus 5, which ends up equal 17. To show it in this setup, I would rewrite my entire equation. So if I get the same format, we are now saying that the f value is going to equal 4, or the x value is going to equal 4. So I need to rewrite this. Did not mean to jump all the way down. There we go. Five minus our 4 value. So notice that this says negative x, and instead of writing a positive 4, we have the negative 4. We want our superscript of squared. So we just rewrite it where our x value is replaced with the 4. Now we can do the math. Let's plug in my value. F of 4 equals, still have the 1/2. Let's see if I can get that. Ah, there it goes. Just jumping around all over the place. Five minus 4 is 1. It is still squared. If I clean this up, without the superscript still, one squared is just 1. You want to do your exponents first, and then we do 1/2 times 1, which would be 0.5. So in this case, I'm saying 0.5 because we have to bubble in our answer. So we need to leave it as 0.5. Go back to my draw tool. Ooh, that was really bad. Oh yeah. For linear transformation, I had to add a little bit to my notes. They were kind of worded in a way that I didn't really like too much, but as the slope of a line increases from 0, so this means that we're increasing the distance from 0, the line becomes more steep. And as the slope of the line decreases to 0, the line becomes less steep. So in this case, as long as our value is becoming farther from 0 in comparison, we are going to have a more steep slope. When we're talking about our y-intercept, our b value, if it increases, our line shifts up. Doesn't matter its starting point. It just shifts up. And if it decreases, our line's going to shift down. Our example here. Our parent function, f of x, is equal to x. It starts at our origin. It goes up 1 over 1. Nothing changes. Our function g, as we can tell, is less steep as it increases at a less rate than up 1 and over 1. So we already know that we're going to be affecting the slope. Slope is what's multiplied to it. So we know that a is not changing what it's multiplied by, and c is not changing what it's multiplied by. Now in this case, we said it's less steep, so we want a number that is closer to the value of 0 than 1, which would be half in comparison to our 2. 2 f of x would be going up 2 and over 1, creating our new line. Problem number 4 says a student graphed f of x equals x, that is our parent function, and g of x minus 5 on the same coordinate grid. Which statement describes how the graph of f and g are related? Now this minus 5 is dealing with our b value, which if we were to go back to our notes, states this is a shift up or down. In this case, because it's negative 5, we're going to shift down 5. So we can look at these. We have nothing about steepness, so we can eliminate the ones that talk about steepness. This one has our word shifted, so does A. It says 5 units for both of them. A says downwards, where C says upwards. In this case, we were going down, so my answer choice would be A. Making a lot better time than last time. But we get to the long work. We get to systems of equations. Now this is a little bit fresh, so we don't have a straight review. You can check one of my recent videos from Unit 5. But for writing the systems, looking at this, it says there is a total of 50 questions worth 130 points on Chanel's history exam. Some of the questions are worth 5 points each, and the other questions are worth 2 points each. Which of the following systems of equations could be used to determine f, the number of correct 5-point questions, and t, the correct number of 2-point questions answered correctly? So this already told us our variables and what they stand for. Correct 2-point questions. F, correct 5-point questions. And it wants us to create the two equations. Now we have a total number of questions, and we have a total number of points. So we would create two equations that deal with totals, which means we're going to be adding some values together. The type of questions that make up the exam were the 5-point questions and the 2-point questions. So we would show that we are adding 5f plus 2t equals should be 30. So this one doesn't work. 5f plus 2t equals 130. Oh, I'm sorry. Our setup, so let me refresh that so I'm giving you the right information. We need to show that just the number of questions adds up to equal 50. So in this case, I need to show that f plus t, my 5-point questions and my 2-point questions, add up to equal 50 questions. So this says my 5-point plus 2 points are 130. This does not create an equation where I'm adding them both up. This one's also missing out. This has my 5 plus 2 equals 50. My 5 points, my 2-point questions equal 50. The other total, which is the points, would include their rates, their individual rates whenever we were adding them together. So this would be 5 points for every 5-point question and 2 points for every 2-point questions, which gives us D yet again in comparison to all the other ones. So you need to make sure that you're keeping an eye on what they're talking about. We have two setups of total values, so I'm showing that I have two equations adding together. Number 6, even though it is in the system of equations, it gives you two graphs and asks let me get to the actual question. Which system of equations can be used to best represent the graph? So in this case, we really just want to find which one of the answer choices gives us the equations of both lines. Well, looking at this one right here, I know it's a negative slope and it has a y-intercept, a b value of 1. So I'm looking for an equation that has a plus 1, does not have plus 1, plus 1, plus 1, plus 1, and at the same time its slope is negative. So my plus 1 has a positive slope. That will not work. And then we have two negatives. So these are two good options. They're both the same value, so I don't have to check to see if it actually is negative 3 right now. My other equation goes all the way down to a negative 8, so that means I'm going to be subtracting 8. D is the only one that subtracts 8. I don't need to go any further because this one makes a mistake there. But if I needed to, I can show that I go up 1, 2, 3, and over 2 to stay on the line. Number 7 is actually a system of equation problem where they want us to solve. It asks for what is the y value. So once I find out what y equals, I am done with my problem. But if I look at this, it already has y by itself, which is a sign of substitution property. This means in my first section, I would say y equals x plus 1 is going to be my equation where I'm going to take an expression and substitute in that value for the variable in the other equation. So the other equation would be the 3x plus 2y equals 12. I have y is equal to a set value, so I'm going to replace y with the set value. Remember when we replace by multiplication, I need to show that I'm multiplying by putting it in parentheses. Now from here, we only have one variable type in this whole equation, which means that I can solve for a value. I can get the x variable equal some value. First, I get rid of the parentheses by distributing. Combine like terms. Subtract the constant. And then divide both sides by the coefficient. So if you're just looking at this at the end, make sure you watch the video so you can get this part. Some people are going to look at this and see all of this work and not really understand what's going on, but I explain it as each step happens. In this case, I find out that x equals 2, but that's not what I'm looking for. This is asking for the y value. So I got to keep going into the last step. This is where I rewrite the first equation. And now I have a value for x that I can use by plugging in. So instead of x, I have the value 2. And when I simplify this, I now have y equals 3. So in this case, since it asked for my y value, that's all I need to know. B is my answer. Number 8 has the same type of setup, but now it wants us to create the equation from a word problem. In the end, it wants us to find the cost of a bowl of soup. So I need to know exactly what I'm looking for. Now, before you get anywhere, you really want to label your variables that you're going to use. I can say C for sandwiches. To see if I can spell this right, even though it's right there. And then S for the vegetable soup. Now, to be more specific, it is the cost of. So you want to make sure that your variables actually represent what they're talking about. So I'm talking about the cost of these items. So now we can set up our situation. We need to find out 2 different equations that we can create from here. One of them, it says Bill bought 2 chicken sandwiches. So 2 times however much the sandwiches cost. And 3 bowls of vegetable soup. And in this case means that we're adding for a total, that's what really shows that we're adding these values, for a total of $16.50. Oops, extend that a little bit farther. We can do the same thing for Sam. Sam bought 1, so I can just write C plus our 1 chicken sandwich and 2 bowls of the vegetable soup for a total of $9.50. So now I have my 2 equations. I'm in the same setup of this section of number 7. Now this time, they are not already solved for a variable, so I have a choice to make. I can go for substitution, or I can go for elimination. Since I haven't shown elimination yet, I'm going to go over that. The way I'm going to go about that is I'm going to multiply this bottom row I'm going to multiply the bottom equation by a -2. When I do this, this will cancel out my C variable, which will give me exactly what I'm looking for, my bowls of soup, when I add them together, that is. So now that I know what I'm going to multiply so that I can eliminate, I can go into the next part if I can. It's just going to keep jumping around. There we go. When I actually multiply this entire equation by a factor of -2, I get -2c minus -2 times a positive 2s is a -4s, and this will equal a -19. Now when I combine these two lines, just to keep consistency with my earlier videos, show that I'm adding them. My c's cancel out. 3s plus a -4s is a -s, and this will equal 16.5 plus -19 will be a -2.5. In this case, it will be $2.50. When I divide both sides by a -1 to get rid of that negative, you will get S equals a positive 250, which stands for a bowl of soup is worth $2.50. If it asks for the chicken sandwich, I would have to go one step further, take this value and plug it into either one of my original equations. Easiest one would be the bottom one to figure out the last piece. Total of $5, which means that it would be $4.50 for each chicken sandwich. Nine is set up the same way. Notice that it is in standard form again, so we can write down our lines. We're doing it in elimination. In this case, I would just be multiplying my first equation by, or my second equation by a negative. So kind of going quickly through this, you can see that I have the 2x plus y equal 4 is my first equation. And my second equation would be now -2x minus 3y equals 12. -12, sorry. And I did my math wrong a little bit there. Negative times a negative gives me a positive, a plus 3y. So in this case, this would be my first section. Instead of rewriting it, I just used it over here, and I showed my steps here. In this case, it cancels out my x. Showing that I'm adding my two equations together. My x's cancel out. Y plus 3y is 4y. And this will equals 4 plus a -12 is a -8. When I divide both sides by 4, the coefficient, you get y equals -2. Now, test trick. I already know part of my answer. I can look at my answer choices, and I can already see that most of my answers are eliminated except for D. I have it. I'm sorry, I looked at that wrong. Not D. Except for A. I would then take this value, plug it into one of my original equations. I should get 3. Another way you can do this, since it is already giving me the values, I can try each one of these in these two equations and see which ones actually give me true statements. In order for the answer to work, such as 3, -2, I need to be able to plug it in both equations, and it should give me a true statement.